What's up, kids? This is Mr. Carlson, C-squared mathematics, and this is trigonometry. 7.2, law of cosines and area. This is the last lesson of Unit 2, that wonderful unit that we loved so much. I'm trying not to be sarcastic here. So we're going to get through 7.2, but before that, bell work. We're going to take the homework quiz, which is now optional for everyone for 7.1, the homework quiz for law of sines, and then the actual lesson. Now, this lesson is, of course, way easier just because, well, maybe not of course, but it is way easier because it's really just plugging things into the formula, and that's going to be fantastic for us. It's not going to be ambiguous like the law of sines is, but I have two questions I want to go through with the bell work. One application question and then one actual question over the ambiguous case, so we can get you prepared for the law of sines homework quiz. Fantastic. So this is the first question we want to get through. And now when it says this, when the angle of elevation is just this right here. So this right here, 65 degrees, goes up. And as you're seeing up, that's the angle of elevation. So I just want to make sure you remember that. But that angle is 65 degrees. The telephone pole is tilted at an angle of 8 degrees. So this angle of 8 degrees right here is kind of corresponding to this. Now this is a right triangle, okay, but then it bends a little bit, like bends 8 degrees. So we're going to use that when we find B in a little bit, directly away from the sun that casts a shadow of 18 feet long. Now, the main thing we want to know is determine the length of the pole. Determine the length of the pole. So if I want to know the length of the pole, we can call this C, because that's A, that's B, and the length of the pole is lowercase c. Do we really want to find B here? Well, we don't, but I think we may have to in order to, because this is an oblique triangle, because I want to know what this triangle is, right? This right here in red. In order to find what this triangle is, I may have to find what B is, even though that's not what it's asking me to find. So what's my first step? Well, the first step is I'm going to try to solve for B. I need to find my missing angles. This is probably the easiest because I know B is 90 degrees, but then B is also minus 8 degrees because it's 8 degrees tilted. So that means it's really just 90 minus 8, which of course gives me 82. So that's B. Very simple, short, sweet, to the point. Now, what is A? Well, now I can just solve for the rest of the angles. So I have 180, A equals 180 minus 82, which is B, and then minus 65, which is C. And when I do all this, this actually equals 33 degrees. Now, when I get to this point, I now need to start setting up my proportions. So let's find B first, because I honestly need to find B, one of these missing side lengths, in order to find C. Because I have B, which is right now 82 degrees, and then I have C, okay? Now, there's a couple ways to do this. You could solve for B, and that would take probably the longer route, and that's completely fine. You could solve for B and set it up like this. So B all over sine of 82 equals, and then 18 all over sine of 33. Okay, now 18 is just going to be right here, this length, and then all over sine of 33 because A is 33 degrees right here, and then you can find for B. Now the problem with this is, pay very close attention. You're kind of doing extra work, are you not? I mean, think about it. Think about it. You have A as an angle, and you have A as a 18 degrees for the side length, right? Yes? So you have both of those. Now, if you wanted to solve for C, which is really what you want to solve for, that is the length of the pole. Do you already have C as an angle measure? Yeah. So think about it. Do you really need to solve for B first and then go for C? Not really. So you have to think about these types of problems, what you're actually trying to find. What are they actually asking you to find? You don't really care about B at all, and you don't need to find B in order to find C, my side length, the length of the pole. So I'm not going to do that. Instead, for my third step, what I'm going to do is use what I'm given, what I found, and that is 18 all over sine of 33. So this is my A's. Now I want to find my C's. So my C, I don't know. That's the length of the pole. And then this is all over sine of 65 degrees. Sine of 65 degrees. Now when I cross multiply this, I get C equals 18 times sine of 65 degrees all over sine of 33 degrees. And of course, you can plug this on Desmos as you guys, if you watched the previous video, you should be able to know how to plug this on Desmos or on just a regular calculator. But what you get is 29.95 feet. Okay, and this is the length of the pole. So notice how you didn't need to find B, even though they kind of already implicitly put it in there as like, hey, find me first. You don't need to find it first because this is just very simple. If you didn't know what B, the actual angle, was here, then probably you would have to do it this way or some other way. But this is actually very simple since they told you that this was an 8-degree difference. You knew what B was, it's 82 degrees, and then you can find what A is, and then you can go from there. Okay, so that one's not that bad. Sweet. Let's erase this and let's get to the harder question. Law of sines, the ambiguous case. How do I solve this? Okay, I am going to be utilizing Desmos. I'm probably going to be utilizing, this is from my previous lesson. I'm probably going to be utilizing the same thing because I am going to be solving for B1. I am going to be solving for B2. I am going to be solving for, all this. And honestly, if you did this almost exactly verbatim like this, you could probably save it and just label it like law of sines because that would probably be very advantageous for you. Why is that? Because then all you have to do is just change these numbers and everything else calculates for you. It's pretty great. So I'm going to do that. Watch. So I'm given A, B, and then A as my angle measure. All right. How do I know if it's two triangles, though? I mean, if it was two triangles, I definitely will be using this. How do I know if it's two triangles? Now, remember our tests. Okay, so this is my first step. My test is going to be A is greater than B times sine of A. This is going to be one of my tests. My other test is A is greater than B. Okay? Now, this is actually the test for one triangle. All right? So if it is, this is the test for one triangle. Now, if this actually becomes greater than, and this is less than, not greater than, then it will be for two triangles. But right now, this is just a test for one triangle. Let's see if it's actually one triangle. Okay, so my A is 11. This is greater than my B, which is 12.2, and then times my sine of 41 degrees. What will this equal? This is actually 11 and then greater than 8. So this right here, if I plug into Desmos, this is actually 8, or a calculator, I get 8. Okay, so that checks out. Still, it could be one triangle or two triangles. Which one is it? Now let's solve. This is 11 greater than what's my B value, 12.2. Now here's the problem. Is 11 greater than 12.2? No. Okay, 11 is actually less than 12.2, which means this is going to be two triangles. Okay, so that's a quick thing that you had to kind of understand. If this was true, like if 11 was greater than, let's just say 10, if this was 10, if my B value was 10, then yeah, it would be one triangle and then we would solve it like normal, just like what we did in the Bellwork problem previous to this. But since this is actually less than, that means it gives me two triangles. So I'm going to erase this so I have more room, and let's actually go through our actual steps. So what am I going to do? Well, the first thing I'm going to do is check it out. I have A equals 41 degrees and then A equals 11. So obviously I'm going to be using that. And I'm going to solve for B, my angle measure B. So let's do that. I'm going to do 11 all over, and then 11 all over sine of 41 degrees equals. My B is 12.2, and this is all over sine of B. Okay? Sine of B. Now, again, remember our steps. I do want to label this B1 because I need to have, since I have two triangles, I'm going to have two different angle measures here. So when I cross multiply this, long story short, I get B1 equals the inverse of sine times the inverse of sine of 12.2 times inverse of sine of 12.2 times sine of 41 degrees. And then this is all over sine of, or sorry, all over 11, not sine. All over 11. All over 11. So it should look something like that. When I cross multiply, I get this divide by 11 and then take the inverse. So what does B1 equal? What does B1 equal? Well, let's go to Desmos and just literally type it in. All right, so I'm going to go over here. And it's cool because I already have this set up from the last lesson. I already have the inverse here, so now I'm just changing things. So this was 12.2, and then this over here was 40. So 41, change that. And then down here was 11. And so for my B, notice how everything else is changing, which is pretty great, right? It's pretty fantastic. Now, I think I still need to do a couple things. Like I still need to change like my C values here. But pretty much this, like my C1 value is done and solved for. This done and solved for. I mean, I'll still show you how to do it by hand, but this is a great calculator. If you do it this way, everything else kind of calculates it for you. So if you're really wanting to use Desmos like hardcore, you could definitely do it like that, and it solves it like that. I mean, it's pretty great. Again, you would still have to adjust these things down here, at least those two numbers, all right? And these numbers as well. These numbers are a little bit off. Like I would have to adjust this to 41. And this is 41 as well. But, I mean, the vast majority of them are correct. So let's just stick one thing at a time. This is 46.7. So let's go over here. My B1 is 46.7 degrees. Okay, my second step to find my B2. My B2 is actually just 180 minus B1. Okay, 180 minus B1. And so I just go back to Desmos here. I already have 180 minus B1 for my B2, just from yesterday's lesson, and I have 133.3. Notice how simple that is? Really great. So this is 133.3 degrees. Perfect. My third step. Okay, I'm going to do my C values now. So my C1 value is actually 180 degrees minus my 41 degrees for A, and then minus my B1. Okay, so minus my B1, which is 46.7 degrees. So what is C1? Well, again, I go to Desmos, and now I already changed this to 41 right there. So that was my A value. That was my A value, and this is my B value. So I'm subtracting my angles to find my C value of my angle, and that is 92.3. So I go over here. This is 92.3 degrees. What's my C2? My C2 is literally the exact same thing, but it changes one thing. So 180, then minus 41 degrees, minus B2 here. So not B sub 1, but B sub 2. So if I want to find B sub 2, I go over here, and I already changed that to A. This is great. Whoa. That's intense. What is that? That is cool. Let's erase. Okay, great. I already changed this. Okay, I already changed that. This is A. Fantastic. And then this is already B2. So what is my C2 value? About 5.7. So I'd go over here and just do 5.7. This is 5.7 degrees. Perfect. Now, my fourth step is to find my little c's, which is my side lengths. And so now what I'm going to do is do a couple of different things. I need to still use my A values here because I need to do a proportion again. So my A values is 11 all over sine of 41 degrees equals my C1 value all over sine of C1. Now I already know what sine of C1 is, okay? I already know what my C1 value for my angle is. So I already know that. So when I cross multiply, I get C1 equals, and then I divide, I get 11 times sine of C1 all over, and then this is sine of 41 degrees. Okay, so I get that. So what am I going to do? It's going to go to Desmos and type that in. 11 times sine of C1, 11 times sine of C1, and then all over sine of 41. So 11 times sine of C1. So this is really what I need to change right here. This 54 to 11, and then times sine of C1, which is great. And then I was dividing by sine of 41. And so what I get is 16.7. So 16.7. And I'll go back here, and then I'll start writing that in. So 16.7. This is not degrees. This is my side length measure. Now C2. C2 is literally the exact same thing, guys. Nothing's going to change here. The exact same proportion is pretty much set up. It's just going to be 11 times sine of not C1 but C2, sine of C2, and then sine of 41 degrees. Okay, so it's very similar. It's going to be set up similarly. It's just going to be using my second angle for my C value. So 5.7 for that. So what does that mean for us? That means when I go down here to Desmos, down here, I'm going to just type in what I found. It's going to be the exact same thing, but I just type in 11 instead, and then 41. And then I get a smacking 1.7. 1.7. So I go back here, and I just type in 1.7 right in that. Okay? That's probably the easiest way to do these problems when you have two triangles. When you have two triangles here, that's probably the easiest way, is to maybe even do it this way and save this. In fact, I probably will save this right now. So I have done just right now, I've made a Desmos calculator. If you want it, then you can email me and I can email that to you. But I made just a given, so you type in your givens. And so A and A. Now remember, it doesn't always have to be A and A. You may have to change some of these values because sometimes they give you like capital letter C and like the angle C and then the lowercase c. Okay, so you just have to make sure, you don't need to change these A values. You just have to make sure you know which one is technically what is given. Okay, if you're struggling with that at all, just let me know. But this is what you're given. Your side angle. So your angle side, real pain in the butt. Okay, so this is what you're given, your side angle. Okay, and then these are your B angles, and I just put them in there and it calculates it for you. And then these are your C angles, it calculates it for you, and then these are your side lengths. So if you're interested in doing this, so you don't have to do it all by hand, then you can email me and I can send this back to you. But I'm probably not going to put it on Google Classroom unless a lot of you really do want me to put it on Google Classroom. Okay? I just like creating that stuff. But yeah, that way, basically all you have to do is just put in what you're given, and then everything else is just calculated for you. Maybe that's cheating. It's using your resources. All right, get started on your homework quiz, 30 minutes. It's 3 questions. I am almost for certain there's an ambiguous case one on there, so make sure that you go through it very, very clearly. Okay, make sure you're paying attention, or get this calculator or something. I don't know. Do whatever you need to do so you can do it. All right. After that, you're going to get started on the notes. That's 7.2, law of cosines. I can solve SAS. Solve SAS, that should be just solve, SAS and SSS triangles by using the law of cosines. So now there are 2 different kinds of triangles. We didn't do SAS and SSS last video. We didn't do those. Okay, we did all the other triangles, but we did not do SAS and SSS. In this case, we're going to be using the law of cosines. Same thing, how do I use the law of cosines to find the area of an oblique triangle or to solve an oblique triangle? So here is the law of cosines. Now remember, this is on your, if I go to classwork, it is on your master sheet. Actually, I don't believe it's on this one. So, yes, it is. Okay, it's right here. It's on the very, very last slide. A lot of these, like the law of tangents, we're not going to do. All right, we don't need to do that, and we're not going to do the Moeldy's formula. We're not going to do that. So don't worry. We're only going to be doing the law of cosines and law of sines here. So those are the only ones that we're going to be doing. But it is right here for you. So just FYI, make sure you know your formula sheet's helpful. Okay. Here are the 3 things for the law of cosines. It actually is very, very awesome. I'll probably make a Desmos one like this too, because it is just way better, I think, to solve for if you have an SAS or an SSS triangle. It'd just be better, easier to solve for it. I think it would be rather hard for you to kind of put a Desmos link and kind of create a calculator for this one, because there's these interchange. Like, you're not always just using the first equation, a squared equals. You're not always using the second equation, b squared equals. And so on Desmos, you would have to have, like, if you made a calculator like this, you would have to have like a equals blah, 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 b equals blah, 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 c equals. And then the next one, you would have to have like a sub 1 equals b sub 1 equals. It's just really annoying. And it's probably going to take a lot of work, not work that I want to do. So if one of you wants to try to do that for me, that would be amazing. But I'm not going to do that. I'm just going to show you how to do it by hand. So these are the steps, and that's it really for all the steps for SAS, because it's very, very simple. So I'm going to go through one question for SAS, one question for SSS, and then one application question, and then one area question. So use the law of cosines to find the side opposite given the angle. Use the law of cosines to find the angle opposite, the shorter, of the 2 given sides. This angle is always acute. And then find the third angle by subtracting the measure of the given angle and the angle found in step 2. So what is all this going to mean? It's honestly really not that complicated. Like, you really don't even need those steps, and I'll show you why. So I'm given this, and we just need to solve for it. So how do I solve for it? Well, my first step is to recognize which formula am I going to actually use. Okay, that's really what I want to know. If I'm given A and B, do I really need to do b squared equals, like that formula? No, I already know what b squared equals. I want to know what a is, right? So that means I'm going to be using a squared equals, and I'm going to be using the formula that leads with a squared. And that formula is just your b squared plus your c squared, and then minus your 2, and then times your a times b, and then cosine of a. So that is your formula that I will be using. Again, notice what you're given, notice what you need to find, and that will tell you which formula you need to use. Notice what you're given, A, B, and A, B, C, and an angle A, side, angle, side, side, angle, side. Notice what you're given, and then notice what you need to find. I need to find side length A, so that will tell me what side length you need to find. I need to find side length A, so that'll tell me A squared. So let's start plugging this in. I don't know a squared, obviously, or a, but this is 20 squared plus my c is 30 squared minus 2. My a is, that's not a. Sorry. This is BC. It's like, how is that possible? This is BC. My b is 20. Sorry. My c is 30 degrees times cosine. I do have that, cosine of a, and that is 60 degrees. Now, when I start solving this, I can really just plug all of this straight up as I see it in the calculator. And again, that's what I attempted to do before, trying to do this, but it gets really confusing, and I just don't know the best way to structure it. But you can literally type this whole thing, this whole string right here into the calculator, and it'll be perfectly fine. I'm going to show you that when I square root this, because this is a, don't forget to square root all of it. This is going to be 400 plus 900, and then this is going to be minus 1200, and cosine of 60 degrees is actually just 1/2. so times 1/2. This actually equals 1300, and then minus 600. So this is 1300, that becomes 600. And so this will become radical 700, which equals 26.5 roughly. Okay? And that is my A value. Now, my second step really is to use my law of sines here. Now that I know what A value is, watch what I do here. This is going to be 26.5 all over, and then this is going to be sine of 60 degrees equals, this is 20 all over, and then sine of B. I don't know what sine of B is. Okay, I don't know what this is. I already know that this is 26.5. My C, do I really know what C is? Well, I can find C if I know what B is, right? And so that's my third step, trying to follow the steps previous. You don't really need those steps, but those are probably the best. Now, when I solve all this, when I simplify it all, it's going to be something like this. This is B equals the inverse. When I cross multiply and divide and find the inverse of 20, right here, times sine of 60 degrees. Sine of 60 degrees, I'm actually going to evaluate that. That's radical 3 all over 2. And then all over 26.5. Sorry, 26.5. Awesome. So now what does B equal? I can literally plug that into the decimals calculator as well. I'm not going to show you that because I think we should be very familiar with how we're plugging into decimals or the TI-36X Pro. And so I'm not going to show that to you. If we're not familiar with that, that's, I think, a problem. But you should know how to do all that right now. You don't need to evaluate sine of 60 degrees right here. I just did. So that's just going to be 10 times radical 3 all over 26.5 and then the inverse. You don't have to do that though. But what I get is roughly 41 degrees. And now my third and final step, since I know that this right now is 41 degrees, I can just take 180 degrees minus 41 degrees minus 60 degrees, and that will give me what C equals, which is 79 degrees. So as you can tell, this is actually a lot easier than the law of sines, I think. It's really just plug and chug with a lot of different things. I mean, again, if you can figure out how to figure like this calculator, go for it. I'm not going to show you what I put in there because it's not complete, but it may work. It may work. But it's not bad to do by hand either. So that is the SAS. That's the only one I'm going to do there. Let's go to SSS. Use the law of cosines to find the angle opposite of the longest side. Use the law of sines to find either of the two remaining acute angles, and then find the third angle by subtracting the measures found from steps 1 and 2 and 180. Now, this is probably the hard way. I really don't solve it this way at all because I give you a formula that actually tells you what each side length is and how to find it instead of just using your normal law of sines like what they've given you, and then you have, or law of cosines, and then you have to use law of sines, and then you have to, like, that's kind of weird. I'd rather do this. So this is an alternative form, and you can actually add this to your master sheet for trig formulas if you want to. But I actually use this alternative form, and it's really, really great. So the reason why I use it this way is because it's just helpful, because this actually allows me then to solve for each angle measure or each side. So if I'm given side, 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 I need to solve for the angle measures, right? And this is an alternative way to solve for each of those angle measures. And it's actually rather glorious. You don't need to use law of sines at all, not like the previous slide said to use law of sines. That's how Math Excel teaches it in the textbook. I don't teach it like that, and I don't like teaching it like that, because then all I have to do right here is the inverse of cosine of b squared plus c squared minus a squared, and then all over 2bc. And then I found my A. And then, of course, I can do it the same thing here, the inverse of cosine of a squared plus c squared minus b squared all over 2ac. And that will be B. okay, equal b. And I can do the exact same thing for c, right? So I like these formulas because when you're given side, 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 you can really just plug it into this on Desmos, and I'll show you how to do that. I'll plug these in Desmos, and I'll show you. But you can plug these in, and then you get angle A, you get angle B, and so forth, okay? So make sure you have those formulas down because I think those will come in handy. I think those are really nice. Okay, let's go through this example. I'm given side, side, side. So how do I solve this? Well, I'm going to first show you my first step. I'm going to just solve for b. I mean, does it matter? No. So I'm going to just solve for b. So b equals the inverse cosine of this jazz. let me just write out the whole formula. I think that would probably be best. So I know we just said the whole formula just a little while ago, but I'd rather just write out the whole formula just so that we are underneath the same page. Actually, let me erase that. 2 times AC. 2AC. So this is my formula. Okay? So what does B equal? B equals the inverse of cosine of what's A. A is 6, so this is going to be 6 squared plus C is 4, so 4 squared minus, and B is 9, so 9 squared. See how this is maybe a little bit easier without using law of sines on your second step, like that previous example that we had to do. And then this is 2, and then times A, which is 6, and then times B, which is 9. Okay? We can simplify all this out accordingly, and I'll show you how to simplify it, but we really don't need to simplify all this out. We can just plug it in exactly how we see it on Desmos, and then it will calculate for us, which is exactly what I'm going to do. Okay? Now, again, remember, oh, sorry, this is not 9. This is 6. 6 and 4. Sorry. Remember, guys, this is only for side, 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 not SAS, not side angle side. That's what we did previous. You do have to use the law of sines for that, okay? Primarily, for the law of sines, you have to use the law of sines in your law of cosines problem for SAS. This is SSS, okay? So they're a little bit different. How do I solve this? Well, let's go over here and just plug it in. Again, I haven't completed this, so I'm not going to show you like that. But this is just B. Let me just get a blank tab. Yeah, that'll be better. So B equals the inverse of cosine. This is going to be parentheses. So I have 6 squared. Actually, I want to divide this too. Oh my gosh. Let's divide that because that way when I start doing the squares, it actually reads it. So 6 squared and then plus 4 squared. And then this is minus, and then we have 9 squared here. Okay, and then this is all over. And then I have 2 times 6, and then times 4. And that is my answer. But I'm in radians, right? I need degrees. Oh my gosh. So let me put it in degrees. There you go. Okay, so that is my answer right there. 127.2. So I'll go over here and I'll just type that in. 127.2 degrees. Now I can do the exact same thing for step 2, but just a little bit different. So let's find A. So I found B, and that makes sense. It's oblique, right? It's definitely acute. So, acute. Obtuse. It's definitely obtuse. Now this is acute. Now A equals the inverse of cosine of, it's going to be a little bit different. Now it's going to be taking your, for A, it's going to be taking your B squared first, then plus your C squared minus A squared, and then this is all going to be over 2, and then BC. So this is your formula for A. For side, 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 so what does A equal? The inverse of cosine, and then B squared, that's going to be 9 squared plus C, which is 4 squared, minus A, which is 6 squared. This is all over 2 times B, which is 9, and then times C, which is 4. So we can go ahead and plug this into Desmos, and then what we're going to be doing is finding our last side, so C. So C will be 180 minus our B value minus our A value, okay? And we'll do that, and we'll find an answer for C shortly. But let's find an answer for A first, and then get to it. So A. Really, I'm gonna copy this. Watch what I do here. I'm gonna copy this. I'm gonna paste it. I'm just gonna change these values. So I'm gonna change that to A. And I'm gonna just scroll over and just type in what I need to type in. So I had 9 here instead of 6. I had 4 still there, and then I had 6 here. And then down here, I had 2 BC, so 2 times 9 times 4, and I get roughly 32.1. So I'm going to go over here and type in 32.1 degrees. Finding my angles. Perfect. Now what we can do is go back to Desmos and then just do the 180 minus my other 2 angles, because the triangle is 180 and I can find C, right? So I'm going to actually do that. Now that I had all these labeled, it's really nice. I can just do 180 minus B and then minus A, and then I get my side length for C, so 20.7, okay, 20.7. So really nice. Desmos fit there, just using Desmos just very basically. Again, I think this would work if I have more time to kind of think about it, but as of right now, I just don't have the time to make a nice little calculator for it. I mean, unless you're actually changing the values over and over and over again. It's too complicated, okay? So that's how you do side, side, side. So we did side angle side, very basic law of cosines, and then side, side, side using a new formula or new formulation of the law of cosines, and we still solved it pretty easily. Let's go through an application question here. This one can be rather tricky, so pay very close attention. The 2 airplanes leave an airport. 2 airplanes leave an airport at the same time on different runways. One flies on a bearing, bearings are coming back, of north 66 degrees west at 325 miles per hour. The other airplane flies on a bearing of south 26 degrees west at 300 miles per hour. How far apart will the 2 airplanes be after 2 hours? Okay, so this one can be very, very tricky here, but they give us a nice picture, which is great. They give us a nice picture. So, of course, you would have to make this picture yourself, unfortunately. But just keep in mind that this is technically your west here. Oh man, that's not a straight line at all. But it's technically your west, so let's do it this way. Is that better? This is your west. Okay. So they kind of travel down here. This is your bearing of south 26 degrees west. That's your bearing here. And then this is north 66 degrees west. Okay? So how are we supposed to solve this? Well, the first step is I want to actually find what some angle is, specifically B. What is my B angle? Like, what is this whole angle here? Okay? And we have to do a couple things. Now, notice, though, that this is a straight line, right? And using what we call the linear property of lines, I can take B equals 180 degrees, because a line is 180 degrees, 180 degrees minus, and then 66, because that's 66, and then minus 26. So what that means is my angle B is actually 88 degrees. So that's really nice to know. Like this right here is 88 degrees. All right. Now, I know what this side length sort of is. I know what that side length is. Okay. And how now the question is this: how do I know that this is 650 and 600? Like, read the problem. Does it give you A equals 650 and C equals 60? And this is what makes this problem so tricky, is because they actually don't give that to you. Okay? What they give you instead is miles per hour. So they say on the north 66 west bearing, it's 325 miles per hour. How can I convert that into just straight up miles? Well, if I want to know it after 2 hours, I take 325 times 2. Why? because this right here, 325, is miles per hour, yes? So this is miles and then per 1 hour. I can multiply this times 2 hours, and then the hours go poofy, and so I'm left with 325 times 2, which of course is 650. So 650 miles, and that's why I have 650 miles there. And same thing here, see, how do I get 600? I take 300 miles per hour right here, 300 miles per hour per 1 hour, and then times 2 hours, because that's how I want to know how much have they flown after 2 hours. The hours go poofy, and that becomes 600 because 300 times 2 is 600. And so that is on the bearing of south and then 26 degrees west. So that's what I have here, south 26 degrees west. That's probably the hardest part of this question here, is that, because they don't tell you that, and you can't use miles per hour, right? You need to know the distance, the actual distance. So 650, 600. Okay, so now that I know that, what am I supposed to do? I have to realize what kind of triangle this is. I have S, and then I have A, and I have S. So I actually have an SAS triangle here, which means the law of cosines. So therefore, cosines. Okay? Now, what am I supposed to do? Well, I can use a squared, right? Because I don't really, or rather, I can use b. Sorry, I'm not going to use a squared. I'm going to use b squared, right? Because I don't know what b is, right? I don't know what b is. So let's try to go through that. So that means I have my a, or sorry, my c. It doesn't really matter which one goes first, but my c, which is 600, and then square that, plus my a, which is 650, square that, minus my 2 times my a and my c, so this is just 600, and then times 650, and then times cosine of my b value here, which we found is 88 degrees. Okay, when I plug this all in, and also don't forget to square root all of this, when I square root all of this, what do I get? I'll actually let you guys do that for me. So after you solve it, after you plug it into Desmos or your TI-36X Pro, you will get 869, roughly 869 miles. So that's how far apart they are. Pretty interesting, right? I mean, that's very, very analytical math, and I think it's very, very interesting indeed. I love that. Okay? Very cool. So let's erase this. Let's get to our last example here, and that's just what we call Heron's formula. Now, this is an interesting formula because it's actually dated so old. It's probably like 2,400 years old. I mean, it's a really, really old formula. And for the longest time, it actually wasn't proved. Like, it wasn't proved. Like, Heron just kind of came up with it, but he didn't know if it actually worked or not. And surprisingly, when mathematicians started dabbling into like aerodynamics and mechanical engineering with regards to like sines and cosines, they actually figured it out that it was in fact true. So, fun fact, we have this example down here, and we'll be done with this. Find the area of the triangle of A equals 12, B equals 16, and C equals 24. Notice how they're all the same unit. That's important. They need to be all the same unit. And this formula is actually very interesting because we actually have to solve it twice. Okay, by twice, I mean you have 2 parts. Now, this is definitely a Desmos formula. I could definitely put this into Desmos and solve it using the area formula. Easy, because all you need is A, B, and C, and then S. But I'm going to solve it by hand. So what's the first thing? I need to solve actually what my S is. Sorry, I actually put these opposite. I need to solve what my S is before I actually solve what my area is. So this is my first step, and this is my second step. So what's my S? What's my half, 1/2 its perimeter? S is 1/2 of its perimeter. So what is that? Okay, so that's 1/2 times, I'm going to add them all up. A, 12, plus B, 16, plus C, 24. When I do this, I actually get 26 yards. Okay, now this is not my answer. This is just 26 yards. Okay, that's technically my half perimeter. which means I had to plug that in for S here into my Heron's formula, my area. And so that means I have A equals, and then I want to find the whole triangle. So this is going to be the area of the whole triangle. So 26, that's my S, 26 minus my A, which is 12, and then I have 26 minus my B, which is 16, and then 26, which is minus C, which is 24. Okay, so notice how this is only for SSS, right? It's different for law of sines. So it's only for SSS. So we need to make sure we only use it for SSS. So what's my area? After I calculate this all together, I actually get 85.3 yards squared. Now they say round to the nearest square yard, so that's just going to be 85 yards squared, roughly 85 yards squared. And that is my formula. And that is my answer. Okay? That is all I have for law of cosines. A lot more simple than law of sines. Is it not? It is. Okay, let's erase this. Let's go to town on the summary. So what did we learn? Learned a couple things. Law of cosines and how to solve an oblique triangle. Solved applied problems also using the law of cosines. Plus side, side, side triangles, oblique triangles, and we kind of did a different formulation of the cosine there to do the inverse. Okay. We also used Heron's formula to find the area of a triangle. Given its half perimeter, side, 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 we can find the area of that oblique triangle. All right. You don't have a homework quiz tomorrow, I think. Maybe you do. I'm pretty sure you do, so don't pay attention to that. I'm pretty sure you do, but it's optional, so you don't have to worry about taking it. Guys, this is the last lesson of Unit 2, so I hope you enjoyed Unit 2. I hope it wasn't too difficult. We're going to do Unit 3 next week, and that's going to be an easy breeze compared to everything we've been doing, which is great. All right, be sure to review for your Unit 2 test. That is not a test to mess around with. You need to make sure you know this stuff, and you have a whole day to review, okay? But until next time, I'm Mr. Carlson. I'll see you guys later.